Imagine standing in an open field when suddenly the sun disappears. You look up, and a shadow stretches across the entire landscape, not from clouds, but from wings. Wings spanning the length of a school bus, attached to a creature with a skull larger than your entire body and a beak sharp enough to pierce steel. The wind from a single wing beat is strong enough to knock you off balance. This isn't science fiction. This isn't from a fantasy movie. This actually happened on Earth. And it happened for over 150 million years. And if you think the Tyrannosaurus Rex was the ultimate apex predator, you're only seeing half the picture. Because while T-Rex ruled the ground with bone-crushing jaws and terrifying power, there were monsters above that made even the mighty tyrannosaurs nervous. Creatures that could pluck prey off the earth like picking up a toy. Predators that struck from angles no ground-dwelling animal could defend against. Hit that like button and subscribe. Because what you're about to discover will completely change how you see prehistoric life. And trust me, you won't want to miss a single moment of this journey. Welcome to a world that existed long before humans ever drew breath. A world where the very air was a battlefield, and survival meant looking not just around you, but constantly above. For over 150 million years, Earth's skies belonged to creatures so massive, so perfectly designed for destruction, that they make modern birds of prey look like harmless insects. These weren't just big animals that happened to fly. These were evolutionary masterpieces, predators that had conquered the most challenging environment imaginable, the open sky. Think about that for a moment. Flying requires incredible energy. Your body needs to be light enough to get airborne, but strong enough to hunt and kill. You need perfect balance, incredible vision, and the ability to maneuver in 3 dimensions. It's the ultimate challenge, and these creatures dominated it completely. Today, we're diving deep into the age when the skies were more dangerous than the ground. We'll meet the titans that soared through prehistoric storms, the hunters that could swallow prey whole without landing, and the silent predators that struck from darkness without making a single sound. By the end of this journey, you'll understand why these creatures were perhaps the most successful predators in Earth's entire history. So strap in, because we're about to take flight into a world that will blow your mind. The Cretaceous world. Travel back 145 million years to the Cretaceous period, the final and most explosive chapter in the age of reptiles. If you could step into this world, you wouldn't recognize Earth at all. The planet was a greenhouse, with global temperatures averaging 10 to 15 degrees Celsius hotter than today. There was no ice at the poles. Instead, lush forests grew where Antarctica now sits frozen. Palm trees swayed in the Arctic breeze. Crocodiles basked on beaches that would one day become tundra. The atmosphere itself was different. Oxygen levels were higher, which may have contributed to the enormous sizes these creatures achieved. The continents were still breaking apart, grinding slowly across the planet's surface. North America and Europe remained partially connected through Greenland. India was an isolated island drifting northward. Massive inland seas divided the landmasses, creating countless coastlines where life exploded in diversity. On land, dinosaurs had reached their absolute peak. Tyrannosaurs thundered through forests, their roars echoing for miles. Massive sauropods moved in herds across open plains, each step shaking the ground. Horned ceratopsians battled for territory. Armored ankylosaurs grazed peacefully, protected by their natural armor. But all of them, every single one, from the smallest raptor to the largest herbivore, had to fear what lurked above. The Cretaceous skies weren't empty. They were highways of death, patrolled by hunters that had mastered three-dimensional warfare millions of years before anything else. These weren't birds. They belonged to an entirely separate group called pterosaurs, from the Greek words for winged lizard. And they were about to rewrite the rules of predation. Pterosaurs. Evolution's flying experiment, pterosaurs first appeared roughly 230 million years ago during the late Triassic period, making them the first vertebrates to achieve powered flight, nearly 80 million years before birds evolved and over 150 million years before bats appeared. Think about that timeline. Pterosaurs owned the skies for longer than dinosaurs walked the earth. They were the original masters of the air. Their wings were radically different from anything else that has ever existed. While birds use feathers attached to modified arms, and bats use skin stretched between elongated fingers, pterosaur wings were made of a sophisticated membrane that stretched from their bodies to a single, dramatically elongated fourth finger. This finger alone could be longer than the entire rest of their body. But here's what makes this truly remarkable. This membrane wasn't just simple skin. Modern studies have revealed that it contained three distinct layers with muscle fibers, blood vessels, and sensory structures that allowed pterosaurs to feel air pressure and adjust their wing shape in real time. They could alter their wingspan, change wing angles, and create air pockets for complex maneuvers, capabilities that gave them enormous advantages. Their bones were hollow and pneumatic, filled with air sacs connected to their respiratory system. Some pterosaur bones had walls thinner than a playing card, yet could withstand enormous stress. This made them incredibly light without sacrificing strength, crucial for achieving flight at massive sizes. Scientists have identified over 200 different pterosaur species, ranging from sparrow-sized insectivores to absolute leviathans. They filled every aerial niche. Some fished in oceans, others hunted on land, some were filter feeders, and the largest became apex predators. Among these species, a select few grew to proportions that still seem impossible. Quetzalcoatlus, the sky titan meet Quetzalcoatlus, named after the Aztec feathered serpent god. This creature was the largest animal ever to fly on planet Earth. Living 68 to 66 million years ago in what's now Texas, Quetzalcoatlus stood as tall as a giraffe when on the ground, approximately 16 to 18 feet high. Its wingspan reached an absolutely staggering 33 to 40 feet, wider than a modern F-16 fighter jet. Despite this massive size, Quetzalcoatlus weighed only around 440 to 550 pounds, lighter than an adult lion. Its skull alone was over 8 feet long but weighed less than 10 pounds because the bones were paper thin and filled with air pockets. Taking off was spectacular. Quetzalcoatlus used all four limbs to vault itself into the air, essentially doing a push-up with its wings. Once airborne, it could climb to 15,000 feet and cruise at speeds exceeding 80 miles per hour, riding thermal currents for hundreds of miles without flapping once. But here's where Quetzalcoatlus gets truly terrifying. It was a terrestrial hunter, a stalk-and-strike predator that specialized in killing on the ground. Picture this. A group of small dinosaurs is feeding in an open area. They don't notice the shadow overhead. Quetzalcoatlus descends silently, lands on its powerful limbs, and stalks forward like a monstrous stork. Then, strike. The razor-sharp beak, moving faster than the eye can follow, stabs clean through the prey's body. With quick thrusts of its head, Quetzalcoatlus swallows its victim whole. This hunting method is supported by where its fossils are found, inland, away from water, in areas that would have been open woodlands and plains. Quetzalcoatlus was a terrestrial apex predator, the sky's answer to Tyrannosaurus rex. Hatzegopteryx, the island monster. While Quetzalcoatlus dominated North America, an even more terrifying cousin ruled elsewhere. On Hatzeg Island in prehistoric Romania, evolution created something truly monstrous. Hatzegopteryx. Hatzeg Island was isolated, developing its own unique fauna, including dwarf dinosaurs, and this nightmare. Hatzegopteryx shared many features with Quetzalcoatlus. Massive size, similar wingspan, but its skull was absolutely massive, potentially reaching 10 feet in length and built like a battering ram. Where Quetzalcoatlus had a long, slender skull for precision strikes, Hatzegopteryx's skull was short, broad, and incredibly robust. The bone was noticeably thicker, jaw muscles enormous, and neck vertebrae reinforced. Why? Hatzegopteryx evolved to hunt the island's dwarf dinosaurs, prey that were tough-skinned and potentially dangerous. It needed power. Hatzegopteryx didn't fly much. Its massive build made it more of a ground predator that used flight to travel between hunting grounds. It would approach on all fours, moving with surprising speed. Its beak, wide enough to engulf an entire head, would clamp down. The neck muscles would twist violently, snapping vertebrae instantly. Fossil evidence suggests its bite force was extraordinary, potentially strong enough to crush bone. Some paleontologists argue that Hatzegopteryx might have been the most formidable pterosaur ever, not the longest wingspan, but pound for pound the strongest and most heavily built. Aramborgiania, the desert phantom. In the ancient deserts of what's now Jordan, scientists discovered fragments of one of the most enigmatic pterosaurs, Aramborgiania. With a wingspan potentially reaching 39 to 43 feet, it represents one of the last and largest pterosaurs before extinction. Aramborgiania possessed an extraordinarily long neck, almost certainly the longest relative to body size of any pterosaur. This neck could extend over 6 feet, yet was incredibly light. The vertebrae were hollow tubes reinforced by crisscrossing bone struts, providing maximum strength with minimum weight. This long neck was a precision hunting tool. Aramborgiania was a high-altitude predator soaring on thermals over arid landscapes, using exceptional eyesight to spot prey from hundreds of feet up. When it located a target, it would descend rapidly, using its long neck to strike downward while still airborne, spearing prey without even landing. The environment was harsh: coastal deserts, salt flats, and seasonal water sources. Food was scattered and unpredictable. Aramborgiania's ability to cover vast distances with minimal energy gave it crucial advantages. It could patrol enormous territories, always searching for the next meal. Tropeognathus, the coastal hunter. Not all giant pterosaurs lived in the late Cretaceous. Tropeognathus emerged earlier, during the mid-Cretaceous in what's now Brazil. With a wingspan reaching 26 to 28 feet, it wasn't the largest pterosaur, but it was among the most specialized and efficient. Its name means keel jaw, referring to the distinctive bony crest running along both jaws. This crest provided stability when the animal's beak was submerged during feeding, and likely played a role in mating displays. But the real weapons were the teeth. Tropeognathus possessed hundreds of sharp, interlocking teeth, perfectly designed for gripping slippery prey. It would fly low over water at high speed, dipping its lower jaw in a technique called skim feeding. When the jaw contacted a fish, it would snap shut instantly. Tropeognathus was an incredibly active flyer with highly developed chest muscles, capable of sustaining flapping flight for extended periods. This made it less dependent on thermals and more capable of active hunting even in poor weather. The Brazilian ecosystem where it lived was a prehistoric paradise for fish eaters, but specialization made it vulnerable. When sea levels dropped and climate patterns shifted, coastal habitats shrank. Specialized coastal pterosaurs like Tropeognathus declined, unable to adapt quickly enough. For over 150 million years, pterosaurs ruled the skies, but every dynasty eventually falls. 66 million years ago, an asteroid roughly 6 miles wide slammed into Mexico. The impact released energy equivalent to billions of nuclear weapons. Within hours, global firestorms ignited. Within days, debris blocked out the sun. Pterosaurs possessed vulnerabilities that made them especially susceptible. Their large size required enormous amounts of food. Their reproductive strategy meant slow population recovery, and they depended on thermals and favorable weather for efficient flight. When the skies filled with ash and temperatures dropped, ecosystems collapsed. Food chains broke down. Flying became energetically expensive. One by one, the giants fell from the sky. Within a few thousand years, every single pterosaur was gone. But nature abhors a vacuum. As Earth recovered, birds, which had survived by virtue of their small size and diverse diets, began to diversify. Over millions of years, some bird lineages began growing larger, filling the niches left empty. 25 million years ago, during the Oligocene epoch, the oceans were teeming with life. Soaring above was a bird that would have looked familiar to anyone who remembered pterosaurs, Pelagornis. With a wingspan reaching 20 to 24 feet, Pelagornis was the largest flying bird of the post-dinosaur world. Its most striking feature was its teeth, bony projections lining its beak, creating a serrated edge perfect for gripping fish. Its wings were long and narrow, optimized for dynamic soaring. By exploiting wind patterns over ocean waves, Pelagornis could travel hundreds of miles with minimal energy, patrolling vast stretches of ocean. Fossil evidence places Pelagornis worldwide, suggesting it was an extraordinarily long-distance flyer. But its large size came with drawbacks. Taking off was difficult. Landing was awkward. In turbulent weather, its massive wingspan made it vulnerable. As Earth's climate cooled and oceans became less productive, Pelagornis populations declined. By about 2.5 million years ago, it had disappeared entirely. While Pelagornis ruled the oceans, another giant perfected terrestrial hunting. About 6 to 8 million years ago, the skies over Argentina belonged to Argentavis magnificens. With a wingspan of 19 to 23 feet, standing 5 to 6 feet tall, and weighing up to 160 pounds, Argentavis was essentially a flying death machine. It belonged to the Teratorn family, giant predatory birds far more formidable than modern condors. The Andes Mountains provided perfect conditions. Strong, consistent winds created reliable updrafts. Argentavis would launch from high elevations and simply ride air currents, covering over 100 miles without flapping once. Its hunting technique was devastating. From hundreds of feet up, using eyesight several times sharper than human vision, Argentavis would spot movement. It would position itself, fold its wings, then dive at speeds potentially exceeding 100 miles per hour, striking with devastating force. The extinction of Argentavis around 6 million years ago coincides with significant climate change. As grasslands expanded and forests shrank, reliable wind patterns became variable. Changing mammal populations may have reduced available prey. Our final giant specialized in something subtle: silence. In the late Pleistocene, roughly 10,000 years ago, Cuba was home to Ornimegalonyx, the giant Cuban owl. Standing over 3.5 feet tall and weighing up to 20 pounds, It was the largest owl ever discovered. Most owls are aerial hunters. Ornithomegalonyx was different. Its legs were incredibly long and muscular, built for running. Its wings were proportionally smaller, suggesting limited flight capability. It was primarily terrestrial, stalking through forests on foot. This made evolutionary sense. Cuba had limited mammalian predators, but abundant ground-dwelling rodents. Ornithomegalonyx filled the niche usually occupied by small cats, but with one critical advantage: it could still fly just enough to be deadly. Picture the hunting scenario. A rodent emerges at dusk. It doesn't see the owl perched nearby. Ornithomegalonyx's specialized feathers silence its movement as it drops and runs forward. Talons, each nearly 4 inches long, pierce the body. The killing bite follows. Total elapsed time under 3 seconds. Evidence suggests Ornithomegalonyx was omnivorous, supplementing its diet with fruit when hunting was poor. This dietary flexibility allowed survival on an island with limited resources. But island specialization is a double-edged sword. When humans arrived in Cuba around 6,000 years ago, they brought profound changes. Forests were cleared. Invasive species competed with native prey. By the time Europeans arrived, Ornithomegalonyx was extinct. And there you have it. A journey through 150 million years of aerial domination. From Cretaceous pterosaurs that ruled an alien Earth to post-extinction birds that rebuilt the kingdom of the sky, we've witnessed evolution's most spectacular experiments in flight. These weren't just big animals. They were perfectly engineered killing machines, each adapted to their specific environment and hunting strategy. What made these creatures so incredibly successful? First, they achieved flight when no other large animals could, giving them access to resources and hunting strategies unavailable to ground-dwelling predators. They could survey vast territories and strike from unexpected angles. Second, they evolved with ruthless efficiency, every gram of weight optimized, every bone structure perfected. Third, they adapted to nearly every environment Earth offered, from tropical coasts to mountain peaks to desert plains. But their extinction also teaches us something crucial. Specialization creates vulnerability. When the Cretaceous asteroid struck, the highly specialized pterosaurs couldn't adapt quickly enough. The birds that survived were smaller, more generalized, capable of eating diverse foods, and sheltering in various environments. Size and power aren't everything. Sometimes flexibility determines survival. Today, the largest flying birds are nowhere near these ancient giants. The wandering albatross seems tiny compared to Argentavis. Why haven't modern birds evolved to match these sizes? Flight becomes exponentially more difficult as size increases. Modern Earth has more unpredictable weather than the Cretaceous world, making large soaring more challenging. And modern ecosystems don't support the kinds of mega prey that sustain these creatures. But their legacy lives on in ways both obvious and subtle. Every time you watch a hawk soar effortlessly on thermal currents, every time you see a heron strike at fish with its spear-like beak, every time you hear an owl fly past in complete silence, you're witnessing techniques perfected by these ancient giants. The sky's rulers may be gone, but the sky itself remembers. So which prehistoric titan captured your imagination the most? Or perhaps one of the post-extinction birds that proved life always finds a way forward? Drop a comment below and let us know which creature amazed you most. And if you've made it this far, you're clearly fascinated by prehistoric life. We've got more videos exploring the most incredible creatures Earth has ever produced, so make sure you're subscribed with notifications on. The age of giant flyers may be over, but their story and the lessons it teaches us about evolution, adaptation, and survival will echo through time forever. Thanks for flying with us today. Until next time, keep looking up